Hi, this is Mr. Max here with Sankofa Mathematics. So I am doing a quick question on coordinate geometry, just a quick revision question. All right, so one of the things you need to know, and I did not type it in here, but I'll just write it. This diagram is not to scale, okay? So do not measure anything. All right, so they are saying that ABCD is a rectangle, and very important that you should know that the interior angles of a rectangle, well, they are all equal to 90 degrees. So we draw these little squares to indicate 90 degrees. And then you have got point A, which is 4,2, point B, which is 2,8, and then they are saying that the equation of this line all the way from A up to C, the equation of that line is nothing but y equals to x minus 2. Very important that that information is there. All right, so something else they say we must find the equation of line BC. So we need to find this equation of this line y equals 2. We'll put it in mx plus c form. So I need to know where will this line cut the y-intercept. If you were together, what is the gradient of this line? Now, the thing about perpendicular lines, okay, like you can see AB and BC, these lines are perpendicular, they meet at 90 degrees. The thing about that, what is important, is that the gradients of such lines, so I'll say the gradient of AB multiplied by the gradient of the line that we are looking for should give you -1. That is the properties of perpendicular lines. So check out perpendicular lines, the gradients of perpendicular lines. The product, when you multiply them together, should give you -1. Right, so let's then calculate the equation of line AB. So first of all, we'll find the gradient of line AB. It's point A and point B. Point A is the point 4,2 and point B is the point 2,8. So they're all in the first quadrant, so this is the point 2,8. Right, so the gradient then of AB is the delta y over delta x. So you take your two y values, you subtract them from each other, you take your two x values and you subtract them from each other. Okay, so I will start with the point B, so I'll say 8 minus 2 over 2 minus 8. So because I started with point B, then I must also start with each coordinate as I go along. You will still get the same if you were to say 2 subtract 8, 4 minus 2, it will still give you the same gradient. So this is 6 over here, and over here you have 8 minus 2, sorry, my goodness, let me just correct that. 8 minus 2 is 4, and 2 minus 8, so 8 minus 2, 2 minus 4. So here is my problem that I was detecting, an error that you can make. So you say 2 minus 4, supposed to be 8 minus 2 on top is correct. That remains negative. That remains 6. So that is 6 over there, and 2 minus 4 is nothing but -2. So the gradient of this line then, the gradient of line AB is equal to -3. That implies that the gradient of line BC should be the reverse of this side, which means a positive, and 1 over 3, because if you multiply these two together, you should get -1. Well, you can create an equation if you want. That is the deal there. All right, so now I know that the equation of line BC, I can actually say the equation is y equals to 1 over 3x, but we're now looking for the the y-intercept, the value of c. So what will happen is we are going to take this value of b because it's common on this line, and we're going to substitute it in this equation in order for us to find the value of c. Okay, so I'm going to take that equation now. So I'm going to say, okay, wait a minute. The equation is now y equals to 1/3 of x plus c, and then I'm going to take point B, which is 2,8, and I'm going to substitute it here. So 8 equals 1/3 times 2 plus c. Right, that gives me that C will equal to 8 minus 2/3. So my C value would then be 8. Let's just have it as an improper fraction. So it will be 22/3. Okay. Now, the equation that we are looking for, the equation of BC is y equals to 1/3x plus 22/3. Okay, so let me just go back there and go write it in. So that is 22/3. Okay, right. So you can actually write it in a different form. You can also say, if you want to, you can also write the equation as there's absolutely nothing wrong with that. So someone else can say, okay, what if I write the equation as y equals to x plus 22 all over 3. So these two things are exactly equal in meaning. Okay, right. Now for the part B, they say we must find the coordinate of C, and here is where you now need to know. To find the coordinate of C, this here, we need to find what is the x value. So let me just highlight. So the coordinates of C, if you were to write them down, so we want to know what is the x value and what would be the y value. So you see this line here, this line BC from here to there, which is represented by that equation, and this line here AC, which is represented by that equation. If we equate those lines, we are going to get the x value of, if we equate them. So we're going to equate equation, just don't mind my handwriting, it's rather terrible. Okay, so if we equate equation, let's say equation AB with equation BC, that is going to allow us to find the coordinates for point C. Okay, right, so let's do that, and then we find the coordinate of point C, and then the x coordinate, and then we then substitute that answer that we find in either one of y equals to x minus 2 or y equals to 1/3x plus 22/3 to find the y value, because they share a common point. All right, so that means I'm going to say, if I now equate the two, I'm going to say x plus 22/3 should equal to x minus 2. Well, I'm going to put that over 1, and I'm going to put these expressions in brackets. Cross multiply, and you will have x plus 22 here, because 1 times anything will just give you that. This is 3x minus 6 if you were to multiply or distribute that 3 over. Okay, hope you remember. This is your algebra should be sound. So this is an equation. So you have got 3x, and then obviously you are going to subtract another x from that because you want to have all the like terms together. You have 22 here, and then you get that constant 6, and it becomes a plus 6. So at this instance, we are now going to have 2x is equal to 28. Therefore, the value of x would be half of 28, and that gives me that the x value is 14. Now, I can use any one of my equation to find the y value. So you can say, let's use the equation y equals to x minus 2, and then we substitute our x value. In this case, it's 14. If it was a negative here, I would be putting it in bracket, but anyway, the y value is 12. Therefore, the coordinate of point C is nothing but 14 for x and 12 for y. Okay, now I'm going to go back, and I'm just going to put it on my diagram because I always like to have them there. So that is the x value is 14 and the y value is 12. Okay. The last question on this particular problem, it says find the length of AB. So again, the length of AB, okay, there's some Pythagoras issues involved here, because you are looking for the length of AB. So remember, if you're looking for the length, it means we need to find what is this distance here, all right, divided by the distance there, or not divided, but the square of this, because you can see this is a right angle triangle. Okay, so I'm going to write my points A and my points B down. So basically, if I was to, before I go there, if I was to subtract the two y values in order for me to find this distance, that's 8 minus 2, this distance here is 6. And if I was to look at the x value here of 4 and that x value of 2, and if I subtract, I get 2. So in essence, we have a right angle triangle, which is 6 there and which is 2 here. And this is the distance we are supposed to calculate. Now, I hope you're familiar with some Pythagoras theorem on how to find the value of x there. But what we have is we have coordinate points. So I'm just going to redraw that here so that it can be a bit easy for you to understand. So I made a right angle triangle. It's rather, yeah, but you get the point. So that was the point 8, 2. And the other one was the point, let's just check, point A. Our point A was nothing but 2,8, 4,2, 4,2, and 2,8, 4,2. So this one here is 4,2, and this point here, let's go back, 2,8. So that point there on top is 2,8. All right, so 2,8. So remember I was saying this is an x value and that's a y value, that's an x value, that's a y value. When you want to find the distance here, you have to subtract, you say your y values, because this is the exchange in y, delta y. So you find this by saying 8 minus 2, which gives you 6. So I will say this is what I'm going to do. So it's 8 minus 2, all right? And then I find this particular point here, which I will call delta x. That is the exchange in the x values. That is going to be 4 minus 2. 4 minus 2. Or you can say 2 minus. It doesn't really matter because I started with that 8. Let me start with the other one around. But I'm actually trying to indicate to you the actual distance, which has to be 2. But if I was to write it here in this formula, okay, I will start with the x value of 2 because I started with the 8 value there of the second one. So I'll say 2 minus 4. Anyway, anything that you square will give you that answer. So since I said this involves some Pythagoras, so this is basically what you're going to get. So eventually, it all boils down to you now finding the answer. So that's negative 2 squared. Anything that you square will be positive, and that will be 6 squared. Can you see that? It would be the same as saying 2 squared plus 6 squared in order for you to find that right angle triangle, okay, in order for you to find this distance of x, okay, the distance from here all the way up to there. Okay, so anyway, you now, it's just a matter of calculation. So the distance of AB would be nothing but 4 here plus 6 squared, which is 36, and that gives you the square root of 40, and you can say that the distance of AB is equal to root 40 or the square root of 40 units, whatever that is. So sometimes they might ask you to give that answer to 3 significant figures, and then you do so. Okay, so you've seen that it involves quite a lot of working through, especially referring every time back to your diagram whenever you have such a problem.